So first of all, anyone has any question, anything about the session, any clarity anyone wants to ask, anything? All good? Okay. Okay. So here, like in this workshop sessions, basically it's 8 weekend workshop sessions, right? So every weekend, some tools we will be going to learn, do practical on that. So before learning, or like we need to install it in our local machine so that we can do practice on that. So it's a manual installation, right? I will be showing it like how a virtual box machine setup we do, and then we can install one by one each tool and component, then we can do practice on that, and we can make it the complete environment except the cloud. Okay. So local on-premises environment we can create. When we will move to the cloud, so cloud is already giving a ready-made cluster, right? If we talk about AWS is giving EMR cluster, right? And Azure is having HD Insight is there, GCP having Dataproc. So all these installations will get it over there, ready-made installation, right? But for local on-premises, right, if we create our own cluster, so that will helpful for us to do practice hands-on, and we can do our learning as well as we can do the development activities. Okay, and I will show you that some job support project like comes, so how you can set up your environment for the project, right? Spark project, and there you can start development by creating a Spark job. So I will show you some like a project. Okay, so that will be give you idea, right? How you can help, how this local setup is helpful, right? Okay, because we cannot set up everything in the cloud. Okay, it's costly for every time, we cannot keep it on, right? Okay. Okay, so first is we need to install the virtual box. Okay, so virtual box is a hypervisor for Ubuntu, right? We need a virtual box hypervisor to like install Ubuntu on top of the virtual box. So we need to install virtual box, and you can take it a virtual box 7. So if you go to the virtual box, this Oracle website, virtual box, so there you can download virtual box 7. So this Windows host you can download and install it. Once you install this, you will get the interface like this. And here you have to create one VM machine. So VM machine is very simple. So before that, you need to download the Ubuntu ISO. Okay, so Ubuntu ISO, you can find, okay, those all links I will provide, okay, because these links are, so latest Ubuntu 23 version you can download. Okay, I have downloaded 20 version, but you can download 23.04. So you can download the desktop image ISO file. Okay, and this ISO file you download once, then you have to configure in your virtual box. Okay, so you go to the virtual box, there is a new option, and here you can give your name of the machine, right? What you want to keep it. So my Ubuntu 1, okay, and you can select your ISO file location, okay, and it is the default Linux version and Ubuntu 64-bit. Next, you have to like, and now here you have to give the host like username and password. So just like giving username and password, like I will log into my Ubuntu, okay. So I just kept it username password, and then I can go next. Here I have to select the memory for my virtual machine. Okay, so I will select depending on your local machine memory, you can decide. Okay, so if you have 16 GB, you can give 10 GB to your Ubuntu so that it can work comfortably. Okay, if you have 8 GB, you can give 6 GB, 4 GB. The remaining memory will be used by the Windows. Okay, when you are running Ubuntu and Windows, both are there. Okay, so here processor count depending on your machine processor count. Okay, And next, you can decide the disk size. I will recommend that minimum 100 GB disk size to keep it, because when we are going to install each and every tool, so it will be taking a more space. Okay, so keep it 100 GB to 150 GB, and that space you allocate. Okay, so once you allocate this space, next you do, and then you can finish it. Okay, after finish, you have to start your virtual machine. So it will take 30-minute time to installation. Okay, once after installation done, you will get the interface. You will get the interface like this, Ubuntu. Okay. Getting this issue, this init IFRMS issue, right? It means your some partition is corrupted, and that is the issue. So we have to run the FSCK command. Okay, and which partition it is corrupted, so we have to do FSCK command. So FSCK command, that generally you will not get it, because I have got it, because maybe like some partition is there. Still file. So once your Ubuntu is installed, right, then you have to log in, and you will get a desktop interface, right? So you will get a desktop interface, so you can install Chrome, and you can install. I have already done, but I'm telling you how can you do that. So you can install the Chrome, you can install it, uh, and now, first of all, before installing Chrome, you have to do, right, this sudo permission you have to give to your user. So whoever user you have, so you have to give this sudo permission, because without that you cannot run any country. So I log in my country. First of all, you can change the display settings, okay? Because you will get a very small minimized size window. So you can change the resolution, and then you can increase the window size. Okay. Next thing is you have to go to sudo su pi sudo and here you have to add your user. I have already done. So you have to add your user, then Control X, Shift Y, enter. Okay, and then exit. Now, once you come to your user, okay, once you come to your user, you can install Chrome. So Chrome you can install by this. Okay, you can download the wget Debian file, and then you can install it. So you will get the Chrome, you will get. And next thing is, like, I want to sharing my Windows content to here. Okay, so how to share that? And I want to copy paste anything like from here. Suppose some command I want to copy from Windows, and I want to paste it here. Okay, so initially you will not get that feature. Okay, so you have to enable bidirectional. So you have to go to your virtual box and go to setting, and here is the advanced section. You go and make it bidirectional. If you make it bidirectional, so you can copy paste bidirectional from Windows to Ubuntu or Ubuntu to Windows. You can copy paste. Okay. Another thing is the shared folder. The shared folder, how to create a shared folder from Windows, you can share the data to the Ubuntu. So shared folder is, we go here. It is not permanent. Here we have to select the folder path. which folder path I want to make it my share folder. Already one share folder I created. Same share folder I'm creating again. Same software. Yeah, we have to give auto mount option. So this I have already given my screenshot. You can see. So here is I have to tell about in my Ubuntu which location I want to share. Okay, so this is the Ubuntu part. This is a directory. I have already created directory in my home directory. Okay, I'm making it shareable. Okay, now I go to my Ubuntu. So this directory is already there. Just this directory will be linked. Now, if I open it, I'm getting my content of Windows. Okay. So I have this image. Okay, I copied there. I will get it. Okay. So these are the two ways. Like you can share the data because most of the times I want to share something from the Windows and I want to get it in my Ubuntu. I can get it. Okay. Now, next is I'm going to install the Hadoop installation. Okay. So first we install Hadoop, then I will start from the basics, okay, learning, okay, what is the big data fundamentals and the Hadoop. So once my virtual machine is ready, right, so I can install first, start from the Java. So I have to start first Java. So I will do sudo apt update. Everything I have to install in my home user. Okay. I'm not creating another user. I'm not creating a user. I'm just doing every installation in my home user. And one more directory I will create here. There I will keep it all software I will install there. So I will create a one folder here, software. Whatever softwares I will install, Hadoop, SQOOP, everything I will keep it with. From very scratch, if you follow the same steps, so you can do it the same. I'm installing the GDK8. I will check and verify in Java version. Next is install the OpenSSH server and client. Okay, so this is like for the passwordless authentication, right? SSH connection. So we need to install it. Okay, this is not part of the Hadoop installation. This is general we do because this is our new Ubuntu setup, right? So we need to install this OpenSSH server and client. So this is like a utility, right? This utility we use for it will not ask every time the password, right? Like whenever we are connecting to the Hadoop services, there are the 5 services are there: name node, data node, secondary name node, resource manager, node manager. So it will be become passwordless. So it will not keep asking password. So this SSH, open SSH and open SSH client. This step you don't need to do. This step, add user, we don't need to add. Okay. So everything we are going to do in our own user. Okay. So we are not adding the another user. So what is the problem, right? If I add user Hadoop, right, and install Hadoop in this user, so everything you have to install in this particular user, and that is a big dependency. So I don't want to keep it any other user. I want to keep it directly install everything in my own user. Now, next is I have to enable the passwordless SSH. So there is a key gen, and this thing we generally do whenever you have seen the GitHub, right? Like whenever you want to code checking, you want to do, so you have to private and public.
Okay.
Please mute yourself if you are not asking. So this is SSH keygen. Okay, so this SSH keygen we need it. And next is we have to move the public key to our authorized key. As it is step I'm following, okay, whatever steps are given here. So I have to give the 600 permission to my authorized key. This is just I'm testing my SSH localhost. Here I can test. So my localhost is connected. It is not asking the password. So this is just testing of my SSH localhost. So it is not asking the password. So this is just testing. Okay? SSH localhost. Now the next part is the download the Hadoop. Okay, because we are going to practice for the Hadoop component, right? So Hadoop is the very basic first component which is needed to use other further component like file, SQOOP. Everyone has a dependency on the Hadoop. So Hadoop comes with the two components, HDFS and MapReduce. Okay, so when you install Hadoop, you will get automatically HDFS and MapReduce, and you can do practice on the Hadoop command and the MapReduce job you can do. But further, if you want to go for file, SQOOP, HBase, GNOME, everything you have to do separately one by one. Okay, but Hadoop is a prerequisite. If you have not installed Hadoop, you can't. You can install other, but they will not be properly installed, and they will give you the error while installation because everything is on the Hadoop HDFS file system, right? So all the component of Hadoop means they will be using the storage part of Hadoop. They have the dependency. So Spark is a new like a framework, right? Which is not giving a dependency on Hadoop. There is you can use Hadoop for your storage, but it is not mandatory. Like suppose you want to run your job in the local file system and you don't have any dependency of Hadoop data, right? So you can run your job in the local mode. Okay, so standalone mode you can run. If you have the dependency on the Hadoop file system data, okay, so you can use Yarn mode, okay, in the Spark. But all Hadoop ecosystem component, you need a Hadoop. Okay, so I want to go to my official web page, this Hadoop official web page. Here you have to download the binary. So when I click on the binary, it will give me this link, binary link. You can download this binary. So this Ubuntu, we are installing Hadoop. Hadoop is not like a wizard, right? It's not like in Windows, like an exe. It's like a zip, and we download zip, extract zip, and then we set the home path, and then we can run the binary. We can run the shell script, okay? And then we can run the services of the Hadoop. And other way is if you want to do it, wget command you can use. Copy this link and go to the software folder. And here you can start terminal and then you can do wget command. So that is another way you can do. So in the installation link, you will see they have shown wget also. Okay, so wget, but this link may work or may not work. Maybe this link is correct. But you can go to official web page, and from there you can take the link, this link, and then do the wget. So I have already started download in my download folder. And from there, I will extract it and then copy this Hadoop folder in my software folder. Okay, so that is the next step. So once this is done, once I extracted my Hadoop, then I have to set the configuration. This is the third part of the Hadoop installation. So once I set up all these configuration files, okay, then I will format my name node, and then I can check my Hadoop service. Anyone has any question, doubt in this installation process? The one-time thing, if you have done successfully installed one time, so you will practice permanently. Okay, because critical part or practical that you will do again and again. But this installation is a one-time effort. Okay, if you have done one time, then you can do practice in this installation. So it's going to complete. It's done. This is my complete. I copy this. Then let's see beside this another folder is created. No. I can copy this as software folder. So this part is done. Now next is I have to configure my home path and bin path. Okay, so I have to open the bash RC. You cannot open the bash RC in any other folder. Nano dot VSLRC. So you will go to the end of the file. Here we have to add configuration. So this identity configuration. So here we will change our path. Okay. So here, first of all, I will do one change here in this line. So here it will label down here. So there is equals ABC. And here is I have to change my Hadoop installation folder location. So this is so and what is the version of Hadoop IPF? It's a 3.3.6. 3.3.6. And this is a nano editor. So how to save in nano editor? Control X. It will ask you to come out, shift Y, and then press enter. And after that, you have to do source command. Otherwise, your changes will not be reflected. Okay. Your changes will not be applied. So once you've done this source command, so we are completed here. Now next is we have to set Java home path in Hadoop env.sh. The two ways you can do. One is either you can open a terminal and you have already set it Hadoop home. You can open the file and add this property. Okay, or we can go manual way. You can go to the Hadoop our installation folder, go to etc Hadoop. Here we can get this file. Open this file in text editor, and then we can add anywhere we can add. Better to add in the last. So export Java home. This is your Java home path. Okay. So this is Java home path where the Java is installed. So this Java home path, we set it in the Hadoop env.sh. This is the environment file of the Hadoop. So I save it. Next configuration file change is, you can get it like this command also, Java C command, and then you can find the read link and then you can get it. Like this also you can get this part. And next is a core site.xml. So core site.xml file, this core site.xml file, I have to change this configuration. So same folder, I have a core site.xml here. I open it in editor. Just replace it with this. And here we change it our home user. So mine is this one. So in your case, you will do your one. Just remember it. Okay. And next is HDFS site.xml. HDFS site is another file. So core site is a common configuration of both the component of Hadoop, storage and computation. HDFS site is configuration of storage component. Okay. So here is HDFS site.xml configuration. This configuration. You can copy entire this configuration, override on this configuration, and change here the username. If you don't change the username here, because it will not be able to find the Hadoop user. So it will be not properly installed. This thing you have to remember. Next is the mapred site.xml. So for mapred site.xml, copy this configuration and go to here, mapred site.xml. This file, open in the editor. So yeah, this is the final one. Yarn site.xml. This is the last file. You change the configuration. All things are done. Now we have to format our mainboard. If everything is correctly done, so this command will not be due anymore. Okay. Once this name node format is done, now we can start our Hadoop service. We'll check it. There are the two ways are there. So these Hadoop services are divided into two parts. One is storage services and processing services. So storage services are name node, data node, secondary name node. So you can start either this command. You can either start with this command and then you can start with this command to the your resource manager, node manager. Okay, so two times you have to, two different commands you have to run. In one single command you want to run, so you can do start all.sh. So when you do start all.sh, it will start your 5 services, name node, data node, secondary name node, and resource manager, node manager. This is the Hadoop 3.3.6 version we start. In a real time, right, you will, all these Hadoop services will be running on the cluster, right? Because this is a single node machine. So everything is on the same machine, in the same JVM. Okay? But when you are having a pseudo cluster or distributed mode cluster, they are all machines are like data nodes are different nodes are there. So name node is a one machine which is storing your metadata, and data node is storing actual data. Right? So now if you want to verify our Hadoop is installed properly or not, so you can see total 5 services are coming. Like this JPS is a JPS command, but other than that, 5 services are coming, right? So now if I want to see my Hadoop directory, so I can use Hadoop fs -ls/ command. So it will show me the root directory of Hadoop. Okay. So I have created a first time, right? I have installed it. So nothing is there. I have to create a directory manually. Okay. So I'm creating a one directory in the root by name test. Okay. And again, I will do ls in the root, ls slash. So I will see here the test directory is created, but there is no further file is there. Nothing is there inside this. If I do test, the test will be empty. So if I create a some file, it's there greater than some content I'm adding. This file I want to write into my Hadoop file system. Hadoop access my script command. Then the file name is a my file. The location of the Hadoop file system, the test directory. Now I copied one file to the Hadoop file system. Now I want to see the content of this file, or I want to check whether the file is there or not. So I can do. So it will be showing my file is there. So you can understand here, if the hyphen is there means it's a file. If it's a D means direct. Okay. So this naming conventions, everything is the same as the Linux, right? So that is important. Like if you are going to work in Hadoop file system, you should know the Linux command to. So all the Linux command practice you should have cat command, direct command, find command. Okay, all this command you can use it. So if I want to see the content of the file, that command, press line. I will talk about more on the command, right? We have to see, right? There are around 20-30 commands, so you have to practice. So this is just I shown the how to install Hadoop in our system, so that we can practice for the Hadoop commands and we can do math. Okay, now I start. Next thing is fundamentals. Okay, for the big data fundamentals things. Then we will go to the commands and anyone has any questions so far? So this is a virtual box we have set up Hadoop. Okay, similar way I will be showing the Hive, how to install Hive, because Hive is a SQL data warehouse tool, like where we can create tables and we can load the data into Hive table, partitioning, we can do bucketing, Survey, UDF, and different file format data, right? Parquet, WARC, Avro, or we can integrate Hive with the Spark, Hive with the HDFS, Hive with the SQOOP, right? All those things we can do. But before that, we need to install Hive. Okay, and for Hive, we need Hadoop. Okay, so Hadoop is a prerequisite for Hive. Anyone has question? Okay. So when we start the data engineering, right? So when we say like, okay, I want to become a data engineer. So nowadays, data engineering is becoming more popular because the cloud flavor is coming. Okay. So people are looking for different cloud data engineers, right? They say AWS data engineer, Azure data engineer, or GCP data engineer. So any one particular cloud knowledge is there, but some of the companies, they are not using cloud now. Okay. So they are asking for the on-premises, or maybe in future they may use cloud. Okay. But now currently they don't have that. So they are using on-premises. They are using, so either of the clouds they are looking for, AWS, GCP, Azure, or if they are not using cloud, so they are looking for on-premises. So on-premises, they are using Cloudera cluster, Cloudera or Mappa. So these are the different vendors out there, Mappa, Cloudera, or Hortonworks cluster. So these are the on-premises cluster, right? So when we are talking about, when we learn the on-premises, like first, right, we understand this all installations, and then we learn on-premises. Then if we move to the cloud, so cloud is just giving an additional thing is, it is giving a ready-made installation, but ultimate work will be the same. Whatever you do, analysis you do, ingestion of the data you do. So mostly when you are working on the data pipelines, right, you are working on the data pipeline. So when you say you are working on the data pipeline, so most of the time your task is, your story is assigned to you, that will be a data ingestion. Data ingestion of the data is coming from the various sources, file system sources are there, like CSV, JSON, XML, Parquet file, Avro, ORC. These are the different file format data. Some are the human readable files and some are the compressed file formats are there. Corner file format is there, row oriented file format is there, schema evaluation support is there in the Avro. Every different types of files are there. So we have to learn how to ingest the data from these different file formats, because we cannot know what type of file format the companies are using. Okay. Maybe they are using only CSVs, they are using only JSON, they are using all three, or they are using Parquet also. So they can use anything. Okay. So data cannot come only from the file system. The data may come from the SQL databases also. We should have knowledge, right, how to ingest the data from the different SQL databases. So only one SQL database is good enough to know, because other SQL databases will be following the same way, JDBC, right? We connect any database with the JDBC, Java JDBC connectivity, and we can get the result set, and we can do our CRUD operation, right? We can write data, we can read data, we can delete data. So we can programmatically, we can do. If we are directly dealing with the SQL, so we write a SQL queries, right? We know, right, SQL clients, right? Some client tool we can use, and we can connect to the database. Okay. So if I say MySQL is enough, right? So we need to know how to read and write data from MySQL and get a data in the Spark or Hadoop file system. So there is a SQOOP processing there, okay, for ingestion of the data. So when we are working on the data pipeline, the first thing is data ingestion, because without data ingestion, we cannot do the data analytics. So Hadoop is primarily going to focus the analytics on top of the Hadoop file system. So if our data is not there on the Hadoop file system, we cannot do the analytics. Okay. So we are installing, but if you are going in the cloud, so it is not mandatory you should have the data on the HDFS. Even your data is in S3 bucket or Google Cloud Storage bucket, right? Or Azure Blob Storage, you have the data, you can do analytics. Okay. So cloud is a different thing, because their data is mostly data in the file system is there. Once the data is landed from the different sources. Okay. But when we are talking about on-premises, so our primary like a storage is HDFS, right? Where we are doing the analytics on top of Hadoop file system, we are doing the analytics. So ingestion tools are there, like SQOOP is a one ingestion tool, and Plume is another ingestion tools for the semi-structured and unstructured data. Semi-structured and unstructured data, we use that. So when we are talking about different clouds we are working on premises we are working on the data pipeline, so data ingestion and data analytics. So for data analytics, there are the different tools are there. Hadoop is providing, MapReduce is a one tool, Pig is a one tool, and Hive is a one. But nowadays, Pig is nobody using. Last 5 years, it is completely outdated, because only the company which like Pig is originally given by the Yahoo. If you are working in the Yahoo project, so definitely you will have to work on Pig, because that is their proprietary tool. Hive is originally given by the Facebook. So, but now these tools are the part of Hadoop ecosystem component, right? Pig, MapReduce, and Hive, SQOOP, HBase. Now they are Apache foundation, right? So they have this component. Okay. So when we are going to start the data engineering, so we need to divide our the whole path into 3 sections. One is on-premises component. So why is still needed on-premises to learn, right? Why is still needed? Because if we know basics of our data engineering, that is on-premises, right? Like basically understanding about the Hadoop ecosystem component. When we are doing Spark, right? So Spark will definitely sometime it will interact with the Hadoop file system, because the data ingestion is mostly done on the Hadoop file system, because Hadoop file system is designed in such a way which can handle large amount of data. Okay. So when we are having a data very huge files, we cannot do the analytics without Hadoop file system. Okay. So on-premises component knowledge we should have, right? Or all different components are for different purpose. Okay. So if I say HDFS is storage file system, right? So HDFS again divided into the 2 parts, right? Like name node and data node. Okay. So it's master slave architecture. So name node is a master, and it is containing the metadata about all data. Okay. This is very common terminology I'm just talking about. So metadata about data node of all the data nodes. So if I say any data node failure is done, or how name node is keeping track of all the data nodes, so there is a heartbeat mechanism is there. So every 10th of second, the name node is sending the signal to the all data nodes. Okay? And any data node is not responding back, so name node will find another replication factor is there, that is basically providing the same block of copy of one data node to another data node. So whenever client is interacting, like any user is asking, right, I want to read a file from the Hadoop file system, or I want to write a file to the Hadoop file system. So our point of contact is a name node, and name node will identify for this particular file, the user is asking how many data nodes having the data, and it will be allocate those IPs of the data nodes to the user client, and client will directly start reading those data nodes. This is the terminology the Hadoop files Hadoop is using. Okay, so it's a basically the master slave architecture. Name node is master and data nodes are the slave, and these are the actual data. So actual data is stored in data node, and one more storage component they give in secondary name node. So in 2.x, even the 3.x is also secondary name node is there, but now the newer version of the Hadoop, right, in the 3.x, they have given the newer concept standby name node. So standby name node is a passive name node, standby name node. So this is a passive name node. This is a passive name node that will become active name node once your actual name node down. So one more thing is here, this name node is a single point of contact, right? If name node is down, entire cluster you can't access. Even your data is there, all the data nodes, but name node will identify the metadata, right? Okay, which data node you want to access. Okay, so in secondary name node, there was some problem, right? It takes a 30-minute time to sync the data. So it takes 30-minute time to sync with name node. Okay, so that is the reason your 30-minute request will be going to delay. Okay, so in the passive name node, they have given one active and one passive. Okay, so whenever this active and passive, right, they are syncing the metadata with some other third node is there, that is called journal node. So this journal node is syncing the data every minute. Okay, so any point of time, if your name node down, then this passive name node will become active. Okay, then this is the architecture. So we can go through more in the architecture detail. Okay, like Hadoop 2.x. So initial version of Hadoop is a Hadoop 1.x, then Hadoop 2.x, and now Hadoop 3.x, which we are using. So Hadoop 2.x and 3.x almost same, like whatever the yarn architecture and this name node, this passive name node, active name node, standby name node concept, all is there in the 2.x and 3.x code. Okay, so there was a major change between the 1.x to 2.x. Okay, so 1.x there was no standby name node, but 2.x onward they have given the yarn architecture. So yarn architectures, so yet another resource negotiator. So they given like initially whatever services you see, right, name node, data node, secondary name node, and now you are taking the resource manager. This resource manager name was the job tracker. So job tracker was doing the same thing what resource manager is doing, but resource manager is doing the extra more thing, is managing the resources also, managing the queue also. But job tracker was only dedicated to just assigning the task to the task tracker. So there is a resource manager. Okay, and the newer version, we have node manager, and the earlier version of there is a task tracker. Okay, so task tracker and job tracker. So all the data nodes contains this task tracker. Okay, so job tracker is a master for all the task tracker. So job tracker is sending the signal and finding the task tracker is working or not. Okay, so sometimes now data node, if task tracker is not working, so job tracker will assign the another task tracker to another data node. So this concept was there in 1.x job tracker. So some limitation was there in the job tracker and task tracker. So they have introduced resource manager and node manager in the architecture performance related. Okay. So in the 2.x and 3.x, So version is more enhanced in terms of storage as well as the processing. Okay. So now we come to there are in the beginning, right? Okay, I didn't cover those slides, but I will go fast forward. So these are the like traditional one, right? And you can go through it. I will share the PPT. Okay. So this is different layers are there, right? In the like data ingestion layer is there and processing layer is there, storage layer is there. So if you are using the cloud, different cloud, so their storage layer is there. And we have a different tools are there. So if we say like visualization layer is there, query layer is there, analytics engines are there, machine learning, data science is there, all and some social media like our email communication. So we are getting data from anywhere. Okay, so when we are writing the pipeline, so there are maybe two types of pipeline. One is a batch pipeline, another one is a real-time data pipeline. Batch pipeline generally we use for the historical data. The data is already there in our file system and the SQL database or NoSQL database. So there we use the batch pipeline, right? The batch is the job will be running in the batches. Okay. Another one is a real-time processing. Most of the times the data is coming in a real-time fashion, right? If I say the credit card swiping data, or we can say we are getting the data from the Twitter, right? So streaming data is there. So when I say some data which is coming like a streaming, right? We are using some Kafka, or we are using some streaming tool we are using, and we are consuming the data and giving to our Spark or any analytics framework. So Spark can handle both, right? Spark can handle real time and batch both. But Hadoop MapReduce. So I told you MapReduce is the analytics engine, right? So MapReduce can do only batch. Okay. So still we need to see MapReduce. We have to learn MapReduce to understand the concept of MapReduce so that we can understand other Hadoop ecosystem component, how they generate MapReduce. Okay, if I say MapReduce have the map function is there, reduce function is there, and shuffle and sort. Okay, so this is the process of MapReduce. So first is MapReduce is doing map job, map task, and then shuffle and sort, and then finally it is doing reduce task. So map task is just splitting the data into the various machine, and these machines will be processing parallelly. And shuffle and sort is basically aggregating the result from the different machine to bring it to the same machine, like based on the some common key, right? If I'm doing the word count, I will show you, right, how the MapReduce works, okay, internally. But we need to learn MapReduce because the other ecosystem component, like if I say Hive, SQOOP, HBase, everything is generating the MapReduce in the backend. Okay. Because MapReduce, why nowadays people are not using, because we have to write Java code, and it should be 200 lines of code for simple word count program. Okay, simple word count program. Just I'm assuming it like this is like the 200 lines of code I'm writing, and just for the simple word count. If I write it this same code, if I want to go for Hive, just it's like a one line of code. Just I do select count star. So just I do select count star from table, I will get the word count. Okay. So how quickly you can write a code here and you can write a code here. But still we need to learn and understand the MapReduce concept, because this query is generating at the end of the day MapReduce. Okay. It is generating the mapper and reducer in the backend. So we need to understand how the queries and SQOOP job, HBase, how these are working. Okay. Internally, how they are generating the MapReduce. So MapReduce concept is important to learn. If you are not getting a chance to work on the MapReduce job, most of the times, like 200 lines of code, nobody will ask if anybody ask me. Okay, so this is like a high level overview I'm just talking about. Like later I will be showing you the code and like understand code and what are the MapReduce concept are there. Not only MapReduce, there are the partitioner, combiner, okay, map side join, reduce side join. So many other different concepts also there. Okay. Okay. So this is all the big data terminologies, right? I'm not just going through the like what is the type of different data are there, semi-structured, unstructured, structured. So these are simple definitions, terms are there. Okay. So what are the different V's are there, right? Data, why we call big data is these different V's means data is coming very fast speed, right? So that is called big data. If the data is in very large volume of the data, right? 12 terabyte data is generated in 30 minutes. So that could be really big data, right? Because this kind of data is like sensor data, right? So which is generating data. This kind of data is generated when the flight is 30-minute flight, which is generating this 12 terabyte data in 30 minutes. And the variety of the data is on different forms are there, audio, video, images, text. Okay, so there the varieties of the data is there, and veracity is truthfulness of the data. If data is not correct, right? So that data is no use for us, right? How can we do the analytics? See, we can use the Java or the programming languages for the analytics. So why we go for Hadoop, right? Why we say, right, okay, we should use Spark or we should use these analytics tool. The thing is, they cannot process the large amount of data. They can process like, okay, in one system, I want to process just, I say some MBs of file. I want to process a data. I can go for any programming language, and it is not distributed. They are not giving a big cluster data processing, right? But if I say how Hadoop is written itself in Java. Okay. The underlying language is that Hadoop is Java. And if I say in which language Spark is written, Scala. Okay. So they are underlying framework. These frameworks are using underlying languages, Java, Python, and Scala, right? But they are providing the infrastructure that cannot be done by the plain Java or plain Python, Scala, because they are not distributed. They are not handling this client server architecture. Okay, how this Hadoop is doing. Okay, so that is the reason that the main advantage of using Hadoop big data analytics is like we are going to analytics of the data of the large amount of data. Okay, so these are the typical use cases, like how now every industry is, right? If I talk about the healthcare and banking and insurance, everyone is using the data analytics. And last 10 years, the data size grown a lot, right? Because if I say like in the last 30 years, if I say last 10 years data is 80% of the data size grown, right? So and most of the data we say semi-structured and unstructured data rather than the structured data, because structured data will be very less, right? If I say RDMS database data, so RDMS data will be very less, right? Because they cannot have horizontal scalability. They are vertical scalable. So there the two concepts are there, horizontal scalability and vertical scalability. So when I say vertical scalability is a limitation, right? We cannot have a cluster. So if one machine has Oracle or MySQL or SQL Server installed, okay, so you cannot share data. You cannot share data across all other machines where this database is installed. Okay, so there is a limitation, right? We can increase the RAM, disk, memory, disk, RAM, and CPUs. So this we can increase up to a certain limit. What machine is having a capability. Okay. Beyond that limit, you cannot increase RAM, because suppose I have a disk capacity of 2 terabyte data and I want to process 10 terabyte data. So 10 TB data I cannot process in one machine. I need definitely 5 different machines. So I need a horizontal scalability. So horizontal scalability is basically you have a big cluster, right? You can start from the small cluster to big cluster, you can go. So horizontal scalability is like you can add up a node, right? Number of nodes or machines and create cluster of set of nodes. And there, so your cluster capacity will be the multiply of the RAM and multiply of the disk, right? So you can process the data, and all the machines should have installed Hadoop, so they can communicate with each other. But one node will be in that cluster. One node will be your master node, right? I say that is a name node. Okay. So when I'm just creating a cluster, so I will be making sure, right, one machine will have name node and other machine have the data node. Okay. So Hadoop we are installing on all the machines. So definitely the name node will be on one machine and data node will be all the machines. So when we are installing multi-node cluster installation, okay. When we are installing the single node cluster, so single node cluster, all the services in the one machine, because that will automatically come, okay, because when we installing. So horizontal scalability is the advantage is, suppose I want to have now 20 TB data processing, okay, and I have to add 10 more data node, 10 more data node I have to add. I can add, right, because it's a cluster and it is horizontally scalable. So when I'm just adding the node, when adding a node, so I have to tell my name node these additional machine IPs, okay, addresses of data node. So how this name node will come to know these additional nodes have been added, right, in the cluster. So that configuration we have to change, and this is a manual configuration. This is when you are adding an extra node or deleting the node. So you have to do that configuration, and that is the role of Hadoop admin. That is not the role of Hadoop developer guy. So if I'm a developer, I will be concentrating on writing the applications. I'm working on the application side. I'm writing the application pipelines. I'm writing ingestion of the code, analytics of the data, right? Or some configuration issues are there. So I have to troubleshoot those issues and find the issues, right? So those things I have to do. Okay. So I will be working on the application side, not the infrastructure side. But still we are learning the infrastructure because we have to practice for ourselves, right? I have to do practice for myself. So I need to learn basic installations, right? At least I can do install the softwares and then I can do practice. So this is a concept of vertical and horizontal scalability. So these are the companies are using big data. Okay. So there are the 2-3 terms are there. One is, if I am saying Hadoop is providing flexibility, economic, it's economic because it's an open source, okay, and flexibility means it can handle any type of data. Any type of data, when I say it means structured, semi-structured, okay, any type of data structured. So 3 types of categories: structured, semi-structured, and unstructured. Okay, so structure is like this, all text data is a structured data. It has the fixed dimension. And semi-structured data, okay, unstructured data is the audio, video, image, okay, or this kind of data is unstructured data, which is not having the fixed dimension. And we have to use some processing APIs like image processing, audio processing, video processing APIs to measure the data or just handle the data. Semi-structured, which is having the characteristics both. So if I say this data, if I keep it in a file, so that will be a semi-structured data like CSV file, JSON file, XML file, JSON file, and email attachment, right? So where you have a subject is structured data and unstructured data, like you can say image, you are uploading the image as an attachment. Okay, and it is economical, okay, because it's an open source and it has reliability. This is the main important thing because it has the high availability. So reliability comes by high availability. So Hadoop has the high availability architecture, right? You see like a name node is the, so how many types of failure can be there? If I say name node is a one failure, so there is a standby name node is there, the backup node, standby name node. Okay, so that is a one failure we can avoid. Another failures can be data node failure. Okay, so name node failure. When I say name node failure, the name node failure, we have the immediate backup standby name node is there, and that will handle. If data node failure is there, so Hadoop has the replication factor. So data is replicated on multiple nodes, right? So this replication is by default is a 3 replication, right? 3 block of copies. So suppose you say one block has replicated 3 blocks. Okay. If one node is down, so 2 more machines have the same block of copy. Okay. If one machine is down, so you have data on other 2 machines. Okay. So you have 3 replication factor. Okay. So I think 3 block means 3 different nodes. Okay. So on 2 or 3. three different nodes. Okay, so you can get the data. Okay, and here this replication can be increased or decreased depend on the critical of your data. So by default, the 3 is there on your whole system. But suppose you say, I want to change this replication factor to my one particular file, which is highly critical. So there is a command set rep, and you say, I want to change the replication factor 3 to 5. So just make it 5 here and give the file name test/test.txt. So this particular file is highly critical file. I don't want to use a 3 replication factor. I make it 5 replication factor, 5 block copy on the 5 different nodes. So it will be providing. So this replication is nothing like it's just like a 5 different blocks. So there is a strategy is there. So that is called rack awareness policy. So rack awareness policy says basically you will be keeping, so we have the data centers, right? We know, right? We have the data centers, and data centers have the racks. Okay, so data centers has the racks, and racks has machines. Okay, one rack can have 10 machines, 100 machines. So rack could be as much big as possible. Okay, so we have the racks, and racks have machines. So if I say, so there are the, so what is this? The policy of the application is like one rack, two node, one rack has two nodes, same copy, has two node, same copy. Okay, and the second rack, no, has one node, one copy, has one node, one copy. Okay, one copy. And if my application is 3, for that, the one rack has one node, one copy, and the second rack has two adjacent node, two copies, one copies. Okay, one copy. Okay, so what is the advantage of using this approach? If it is replication factor 5, so third rack will come in automatically in picture. So third rack will come, and the third rack will have again has two adjacent node, one copy in the third rack. Okay, so if I say the free replication factor, so if this node goes down, so if I keep it all the block copy in the same machine, same rack, that is also problem because this rack cannot be accessible also. Okay, so we keep it in one rack, one node, and the other rack, right? If this rack is not accessible, right? So at least we can go for the second rack. So second rack also, if one node is not available, right? So another adjacent node, we can get the data, right? But suppose you say, okay, this rack cannot be accessible also. So what is the solution? So we can go for the third rack. So in that case, we will increase our application factor 5, 7, 9, as much as possible you can do. But that much reliability is there, right? Because we cannot say all the racks will be the same time will not be accessible, right? So we have reliability is there up to one extent. Okay, we can go for the worst case, but we cannot say like all things will happen in the same time. Okay, so this is the way of the data distribution, right? How the racks will be distributed machines, the data is replicated. Okay, so I was talking about here what are the Hadoop features: flexibility, economical, and reliability. That is a high availability. Okay, so these are the features Hadoop is giving. That is the reason, right? Still Hadoop is in the market because the storage which Hadoop is providing, that is basically for the large amount of data. So if I say why Hadoop is chosen like HDFS, so the file system of Hadoop is the block size. You know how the data is stored in the Hadoop. So we generally talk about the data is like, okay, I say 1 GB data. We talk about the data in terms of size of data. We say like MB, GBs, like that. But actual data is stored in terms of block. Okay, so one block is either 64 or 128 MB. Okay, so in Hadoop 1.x, this block size, default block size was, this is in 1.x, the block size was 64 MB. But they have increased this default block size 128 MB in 2.x and 3.x. So why they are making it this larger block size? The advantage is like if you are processing the large file, like less number of blocks will be there. So the design of the Hadoop file system is so much flexible, right? You can accommodate very less number of blocks. So when you are searching your data, right, in the less blocks, so your data retrieval will be faster or processing will be faster, right? So if I say in the Windows, if I compare the Windows file system or Unix file system block size, so you will amazing, right? You will be see here the block size is 6 KB only. So 6 KB is but that is their design. Okay, we cannot say they are processing because Windows having its own file system, Unix file system, right? They are designed in a different way, different purpose. But when we are talking about the Hadoop, the main purpose of Hadoop is the file system for storage plus analytics purpose. Okay, so they designed the block size too higher so that the less blocks, less number of blocks, and the less time to process the data and use files you can do and process. Okay, so that is the reason Hadoop file system, right, mainly used for the storing the data for the large amount of data. Okay. So this is all distributed system terminologies, right? Like, okay, this is a vertical and horizontal scalability. I already explained about this, right? If you have one machine, how much data max you can process or how much data you can process. Suppose 1 terabyte data in your one system, how much time you will take it and how much time you will take it in the 1 terabyte data to process in a cluster of your 100 machine, right? So you can easily see here is a like a foot, like it will be a tremendous difference will be there. Okay, because it will be like parallel processing is there and capacity will be very high. Okay, in the distributed system. Okay, so this is the guy who is the inventor of Hadoop, right? He selected the picture of the Hadoop is a toy elephant because he saw his son playing with the yellow elephant toy. Okay, so he has given the name Hadoop and the symbol of Hadoop is a small toy elephant. So Doc Cutting is a guy, he's right now the CEO of Cloudera. Okay, and basically he is the inventor. Okay, so initially the Google has published 2 papers. Okay, Google File System and Google MapReduce. Okay, GFS and Google MapReduce paper. Okay, these 2 papers published in year 2000. The starting of the big data started from the year of 2000. Okay, but Google has not put more attention on this. This guy has started work on 2004, and he took the inspiration of these 2 papers. Okay, he took the inspiration from these 2 papers and he has given HDFS file system and MapReduce. Okay, and he has given Apache Hadoop. So later on, he donated like this is given to the Apache Hadoop, right? That is we call vanilla Hadoop. So whatever I have installed it on the Ubuntu file system, that is called vanilla Hadoop. But if you are using some distribution, right, like Cloudera, Hortonworks, so they are giving wrapper of this vanilla Hadoop in their wrapper they are giving. So the main advantage of using the Cloudera, right, generally you will get the in companies like Cloudera CDP cluster is there, CDP, CDS, right? Okay, and if you are using this, you will be everything is installed by using Cloudera, and they are giving a community, they are giving us support, right? Technical support, and companies are getting it. Okay, but for learning purpose, we are going to learn vanilla Hadoop, right? The Hadoop features are same. Whatever you learn in the vanilla Hadoop component, so same will be there in the Cloudera version. Okay, so here we are getting extra thing that is our own installation and understand the configuration things, what is behind the tool, right? So that part you are getting more clear, right? But when you are working in the Cloudera, you won't understand, right? Where is the Hadoop is running, what? So everything is a ready-made installed, and whenever you start Cloudera machine, you will be always getting this keep on running. But when you are working in your own installed Hadoop, so you have to manually start the service. When you start your this VM, every time you have to manually run the services. Okay? So this already I have explained, right? Reliable, economical, scalable, like horizontal scalability and vertical, both are there. Flexibility is there. So these all things I'm not going. What is the difference between the RDMS and Hadoop? So RDMS is a database and Hadoop is a platform. So Hadoop is a platform which can support anything. It could be a RDMS database, NoSQL database, or it could be a file system. It could do anything, but RDMS is having very limited scope. It just is structured data, only structured data. Okay, but Hadoop can handle any type of data. So these are the data ingestion, data storage, data analytics tool, okay, visualization tool, Tableau, Power BI, right, and data processing tools. So these are the all combinations, right, in the ecosystem. Impala, Hive, Uji. So these are the different tools are there. So these are the vendors. Like Mapr is a one vendor, Cloudera, Hortonworks. Now the Cloudera, Hortonworks both are merged together. So now it's the CDP. Amazon EMR is the AWS version, SD inside Azure, and Mapr is different, and GCP is a data prop, right? So this is combination of like you can say these are on premises and these are the on premises. These are to the cloud. Okay, so now we do some practical hands-on on the now you basic terminologies things you understand, right? Related to Hadoop, right? So when we are going to start the work in the in the in the Hadoop environment, so we need to bring data. So how to ingest the data, right? So there are the different other ways are there, right? Sqoop is the one way, Plume is the one way, okay? Or we can use the Hadoop command. So first, initially, we are going to start with the simple Hadoop command, how to write a data from local file system to Hadoop file system, and there are the some commands are there. Okay, so when we are starting the commands, okay, our Hadoop infrastructure is ready, right? Our we can already I shown the some basic commands I shown, but some more deeper commands I will be going to start. Okay, so we'll start just creating our own directory, copying the file, and then we will do some commands. Okay, there are the lot many commands are there. Okay, so I show these commands one by one. Anyone has any question to start before the Hadoop commands? The next thing we have to see Hive, or we have to install Sqoop. Okay, all good.
Yes, sir.
Okay. Okay, so Hadoop commands are very basic commands, right? I told like if we have a good command on the Linux, right? So we can easily practice on the Hadoop command. Okay. So Hadoop file system is a virtual file. Okay, we can see this file system on the UI also. So there is a 9870 port is there. So when you open localhost 9870, so you will see here the Hadoop file system, but you cannot do any manipulation. You can just view purpose, you can see. So here you can see the complete Hadoop installation, right? You can see the name node, data node, right? So this all information is showing how much size of your Hadoop cluster. So it is taking off your Ubuntu machine size, because as much as your machine, like your machine where the Hadoop is installed, right? So as much as your disk is there, that will be allocated to your cluster, right? So it will be taken. So data node, like it's showing only one data node is there. So like we have a single node cluster. So it is showing the HTTP address of my node. Okay. So for name node is the same and data node is same. So internally, if you look at here, so this name node and data node directory is created. You remember, right? Temp data. So when we are installing Hadoop, that time one folder we have given in the core site.xml. The core site.xml we given this path, my home username and temp data. So here two folder, name node folder and name node folder. This is your metadata. So this we can't understand how name node is managing the metadata. So there are the two types of files are there, FS image and edit log. So edit log is a disk copy and FS image is a memory copy. So whenever you are requesting any writing a file or reading a file from the Hadoop file system, Hadoop is using FS image copy because it will not read the data, metadata again and again from the disk. So one time your Hadoop is started, this FS image copies will remain there in the memory. But suppose when you start the real machine again, right? When you start Ubuntu again, you start the Hadoop service again. So this FS image copies will be gone. Okay. And edit log file will remain always there because, and this edit log and FS image copy will be always same. Okay. So actual metadata is stored in the edit log file, but whenever you are restarting the machine, again FS image file will be loaded at the time of starting your Hadoop service. Okay. So these data directories are created. So one data directory is the data. Okay. So two directories, name node and data node. So name node containing metadata and data node is containing the data directory. So this is the UI, and here you can see the file system. When you go to the browse file system, so whatever the file we created or directory we created, we can look at here. But we cannot see the content directly here, but we can download the file. If I click on the download, and this file I can open it, what file I loaded in my Hadoop file system, I can see the content. Okay, but here you need to download. Okay, so directly view you can't do. So this interface is mainly used for like anything you are viewing your file system, you can view, right? But you cannot do any write, you can't do. Okay, for that you have to use your terminal. Okay, command line utilities you have to use. So whenever you are using any Hadoop command, you have to use Hadoop FS. So Hadoop FS, when you do, it will be giving you the list of commands. These commands you can use with your Hadoop file system. So you can see the cat command is there, ch group, ch mode, ch on. So these commands are the permission related commands. We know, right, in the Unix file system, if I want to change the ch mode permission, right, 777 or any permission, I can use the octal number. So ch mode is there. If I want to change a group of, you know, right, whenever we do ls. So when I do ls, so I see ll, I do, here is a user and group. So this is my user and default group is a same user, same group, right? But if I create a separate group and I want to change the group, I can use ch group command. So ch group is to change group. Ch on is change the user, owner. So who is the owner here? The person. This is the user, right? The user is the owner. Okay. So this user you want to change, you can do with the ch on command. Okay. If you want to group change, ch group is there. If you want to change this permission, you will use ch mode. So three commands are there to change three different things. Okay. And okay, we will go one by one. Okay, let's see first simple thing, like we see that if I have some local file is there in my file system, ls. So I have created my file and I copied this file in Hadoop file system and I can see the content. Okay, suppose I want to create a multiple directory, the nested directory, how I can create. So when I use Hadoop FS minus mkdir and I write test/test1, test2, test3, it will not create. Why it will not create? Because it's a simple Linux thing. If multiple nested directly you cannot use with the mkdir. Okay, so you have to use -p. Okay, let's try with this one, what it says. It is saying no such file directory. So it is not able to find this test2, test1. It is not able to find. That's the reason it is not able to create the test3. So all together you want to create, just use here -p option. So -p is for nesting level. It can create. Now it is created. So you want to just verify it. So Hadoop FS -ls. You see test, you will see the test1 is there. When you say test/test1, you will see the test2. So nested directories are created, but these directories are empty. Just I created directory. Now I want to copy some file. Okay, I say Hadoop FS. So there is a command, copy from local or put command. So any one of the command you can use and say, I want to copy this my file to test/test1/test2 directory. So I'm just copying the file here. Suppose if I run this command again, what will happen? If I run this command, it will give me the error. Generally in the Linux, it is copying, right? It is not giving any warning because you have to use some alert, right? When copying and moving file, right? You are doing copy paste, cut paste. So there is a -I option you can do that will ask you alert, right? It will say yes or no, right? So, but here is not default. It will give you the error because if you are overriding any Hadoop file in your from the local, it will be a problem, right? Suppose your fuse file is there in Hadoop file system, and by mistake, the same file name you would copy, so your data will be lost, right? So Hadoop is having this error, right? Like if you are trying to copy the same file with the same name, it will give you the error. You can copy with a different name, it is fine. You say here test2/myfile1, then it will copy. But when you are saying my file, you copy in the test2 with the same name, it will not allow. But still you want to do it deliberately, right? You say, okay, I want it forcefully. So they have given -F. So you can use F, then it is not giving any problem. Okay. So this -F, not only you can use put, you can use with the get command, CP command, right? Any command you can use this minus. Okay. So this is like copy from local or put command. Okay. Suppose I have a file is there in my Hadoop file system and I want to get back data in my local file system. So Hadoop FS -get command or copy to local command is there. So copy to local or get, both are same. Like copy from local and put is same. Get and copy to local, both are same. Okay. So get, and then you say, but here, which directory you will give here? You will give Hadoop directory because you want to get the data from Hadoop. So you have to give complete path of Hadoop because Hadoop is a virtual file system. HDFS is a virtual file system. So there you have to use a complete path. You cannot go inside that file system because you can't do CD because it is not possible. Okay, because it's a virtual file system. So when you are going to get the file from your test2, right? So how will you get it? So you say test/test1/test2/ and my file name is my file. And this file I want to get in my local. So in the local, either you give the dot, that is also fine. If you don't give anything, that is also fine. But still it will give the error. What error will be there? If you do dot, it will copy in the local directory. Okay. What error will be there? Because this my file is already there, right? So same error you will get, file exists, right? So if you want to do forcefully -F, it is done. Okay. So -F option is you can apply with copy from local, copy to local, get, put. Okay, any command you can use the -F. Okay. So this is just copying the file from local to Hadoop and Hadoop to local. Just be tested vice versa. Okay. I say I have a 2 file in my local file system. This is another example of I have a 2 file. I'm creating one more file, cat greater than my file 1, and I'm giving some other content. This is my file 1. Control D, I'm saving the file. So now you do, if you do here ls, you are able to see 2 files. Now I want these 2 files concatenate in a one file and write into the Hadoop. Okay. So how can, either one way is like you can do in the Unix merging, like you can, Unix command is there, Linux command is there, you can merge it here and then you can copy. But I want to do it with the Hadoop. Okay. So how to merge it? If I see the content of cat, my file, cat, my file 1. Okay. So the command is Hadoop FS -append to file. So when you give this append to file, it will take 2 paths of your local file system. My file, not only 2, you can give more than 2 or 3 or 5 files. Okay. Or even one file also you can give 2 times. Okay. But at least more than 1 file. Okay. So my file and say my file 1, these are the 2 files. And I want to merge these 2 and write into the Hadoop file system with the name test/test1/test2 and some name I'm giving my file 2. Okay, or my file 1, because there is a my file is there, not my file. So now Now I check it in the Hadoop file system, Hadoop FS minus cat, and I say test slash test1. I have to give complete path, test2 slash my file one. When I do this, I'm able to see that both contents are there. So this is kind of concatenation of the file, right? Not only two, you can merge 2, 3, 5, as many as number of files, but you have to provide all those names. Actually, this command is identifying the first two are non-Hadoop file because it will check it whether this is a Hadoop path or this is not Hadoop path. Hadoop path is always start with the slash, the root path. Okay, so you are starting with the slash root, and after that it will check this is a Hadoop path, and then it will copy all the files, merge it, and then copy it to the in the Hadoop file system. Suppose you have two files in your Hadoop file system and you want to merge it and bring it to the local file system. It is just the reverse, because why I'm doing this command? Because first command I shown you copying the file from local to Hadoop. Now merging the file from local to Hadoop. Now I'm merging the file in Hadoop and bringing to the local. So how can I bring it? Because these are the utility commands, right? This is like when you want to just see the file in your local file system instead of Hadoop, right? So you can, or some modification you want to do in your local and then again copy to the Hadoop file system. So you can use this command. So there is a command get merge. And always remember the case sensitive, right? So here is this n is small only. And now you have two files in the Hadoop file system. So I have to give a complete path because I am using get merge test slash test1 slash test2 slash my file. And another one is again full path test slash test1 slash test2 slash my file one, right? These two files are there. Now I want to get in local. So you know local, you can simply do dot, or you can say, or you can give the name here, my file local. So if I see the content like ls I do, so I get here my local file, get my file local. Okay, so this is the merge content of two files in the Hadoop file system and getting back into the local file system. Okay. So when I do Hadoop FS, I can see all the commands. Okay. So if you want to do practice, so you can see all total number of commands here and you can do each practical, right? The copy from local we see, copy to local we see, right? That is like the, and the count command. Count is just simply giving the number of directories and files are there in your Hadoop file system in a particular path. So Hadoop FS minus count, and you can give some path. So test slash test1 slash test2 to some directory I'm giving. So I will be getting like this is the total size and this is the path and this is the directory files. So it is just giving the count. Okay. So next is like set replication. Okay. If I do Hadoop FS ls command and some path I'm giving test1, test2. And now in this path, if I see the replication factor is 1. Okay, because this is a file replication factor is 1. This replication factor I want to change 1, 2, 3. Okay, because why it came 1? Because my Hadoop configuration I set it in HDFS site.xml, I set it 1. So that is the reason it is taking for any file it will be creating in Hadoop file system will be having default replication factor 1. Okay, and there will be no point of making it replication factor 3 or 5, right? Because this is a single machine. But for testing purpose, we can do because it will create a number of block copy, but it will be remain on the same machine. Okay. So I want to change this replication factor 3. So Hadoop FS minus setrap, and I will change the application factor 3 and save particular file. Or directory you can do, and you can use recursive minus R to make it all files inside the directory. So you can make it setrap for the directory also. So I'm just doing here for the file test1, test2, and my file. When I do this one, now replication factor 3 is set. So now automatically it will create a 3 replicas instead of 1. So if I see again Hadoop FS minus LS, I do Hadoop FS minus LS for this. So I will change, I will see here the replication factor is changed. So this is the setrep command. Go to the Hadoop FS. Okay. So there are the many more command is there. Setrep command. Stat command is just showing the statics. Okay. About it is a date and time it will show, right? Hadoop FS minus ST80. So some command are informative command and some command are the manipulation command. Informative command is just giving the information. That is giving information. It is not doing any manipulation. And it's just one test to directly. So it will be just showing date and time. So it's talking about it. Okay, so other commands are there, like help command is there. You want to see the help of any command. So Hadoop FS minus help command. So Hadoop FS minus help, I say ls command help. So I'm getting the help of ls, like what are the options are there in the ls. If I want to see the help of I say uses command. So uses command is another command. So this all command like we can take the help. Okay, we can do help command. Some more command is there. Okay, if we come to the ch group, ch on, ch mode. Okay, I show that how to change the permissions. So if you look at here, Hadoop FS ls command for this one. So the this ls command you see here, you will see here read, write, w, write, read, write, read, write, and execute permission, read, write, execute. But here is only read, write is there. There is no execute, there is no execute. But I want to set 777 permission. Hadoop FS minus ch mode 777, and I will give the path in the file. Or directory I can set recursively. So I can do. Okay, now it is done. Now I can verify it. So everything, whatever you are doing, you can see in the file system, everything is reflected here, right? So whatever you are doing here, directory you are creating, files you are creating, so you can see here. And if you want to download, you can download and see the command. So, okay, some more commands. Ch on and ch group I'm not doing. You can like change the honor and group, right? Okay. Simply I want to change honor this. Want to change for this particular file. Now I verify it. You see Hadoop is changed. Okay, even the this ch on is able to do the group also, but there is a separate command for the group, right? Ch group, right? So you can change the permissions, change the group also. Okay, mkdir move from local. So move from local and move to local. These are the two opposite command of copy from local. So move is like cut paste. Copy from local, copy to local. This is copy, right? From Hadoop to local and local to Hadoop. Move from local and move to local. It's a vice versa of like copy from local, copy to local, but it's like a cut paste. Move means cut paste and copy means copy, right? You have both places, you have the same copy. But move means like you will have only the copy will remain at one place. So you will be it's like a rename, right? You know, right? In the mv command is there. What is the use of put command? Put command is used for like copy the file from local to Hadoop. So either you can use copy from local or you can use put. Both are same. Okay. So put is basically you give the source file, your local file system, and give the Hadoop file system where you want to write. And And when I come to CP and MB, there are the two more command is there. So CP MB is cluster to cluster. In the same cluster, you want to copy the file one folder to another folder. We can do CP. Okay. So how to use CP? So Hadoop FS minus CP. Okay. Generally CP you seen in the Linux, we use copy from one folder. So in the CP here is cluster to cluster. Either you using CP for Hadoop to Hadoop or Unix to Unix, right? So CP we are using here Hadoop FS minus CP. I'm telling here the one Hadoop directory and the second Hadoop directory. So my one Hadoop directory is this one, my file one, and this same file copy, I want to do it in the another Hadoop directory. So I say here, this is the same directory. I take it here, test and test1. So I'm copying the file from the test2 to test2. So one level down, I'm just copying. So there is a CP. Okay. MB if I do, so here both copies will be there in this directory and this directory, both are the same file. But if I do MB, so it will remove the file. So if I say MB and I say here test directory. Okay, so test directory I want to move. So this test2 copy, the source copy will be removed. So if I verify in my this directory whether the file is there or not, so you will get the error because I have used MB command. With no such file directory. So file is moved. So this is the same like we use in the Unix. Okay. Okay. If I see other command, Hadoop FS. So touch command is there. Okay. Truncate command I show. Okay. Truncate command is like specific characters, right? Like suppose you have a file and you want to truncate existing file you want to truncate. Okay. Like you say total 10 characters are there, only 3 characters you want. Okay. And you want to modify your current file. You don't want to create a new file. You want to, and it is very careful, right? When you are using truncate, and if you use like a wrong way, the truncate, so your file content will be gone. You can't recover. Okay. So it is very careful to use truncate. Truncate is generally used when we are sure like how much content I want to truncate. Okay. So suppose I say I have a content of stat. I see the content of this, and I want only this 5 letters. Okay, so what I will do, Hadoop FS minus truncate TRNUCAT, and I say minus W is for waiting, right? And I say my file path. Okay, slash /1 +2. If waiting is coming. And now this length is truncated to the file. Now, if I see the cat, this file, okay, only hello is coming. So this will modify your current file. Okay. So one more command is there, touch command. Touch is like you are going to create an empty file to FS modules. Simple touch G or touch O, anyone you can use. Can truncate your file announced. I think so. It will not be. I have not tried because it will. Well, it's a character, right? Because it is applying on the character. Because in the images we have pixels, right? Okay, so touch I will use, and here I want to create a new file, empty file I want to create. Sometimes I create an empty file and I will load the content in the file. So the test1 to create if I say Hadoop FS minus scan, so there will be no content. Okay, so touch and touch G both are same. Can use either one. So this command is, this is empty file. Okay, so one command is very, very important, one tail command. Okay, and that is used right when you are storing the logs right in your Hadoop file system, and you want to keep checking your log, right? Tail command have you seen in the Unix, right? So generally we want to keep appending the logs, right? Just streaming data is coming, and you want to check your log every time, like last 10 lines of logs. Okay, so it will keep updated. So okay, the tail command, if we see here, so it is for some file, right? Tail. Okay, so I want to do the tail of some file. So when I say Hadoop FS minus tail, I have to provide a file name, and then I will be doing. Okay, so if I say Hadoop FS minus tail, and I give the path S1, S2, slash my file. So we take the example is, so if you are showing minus F, then it will be holding the file. Now, have you seen the what is the difference in these two? This one is entire file content is showing as a tail, right? Whatever. But if you say minus 10, you say minus tail, because here it's only one line. So I have not given the line numbers. Okay. How many lines I want. So minus tail, minus number you can give. Minus F means a particular file you want to hold it. So if you see this file is still waiting for the content. This file is waiting for the content. But how this file will get the content? Okay, so I will manually produce the content, right? I will open another terminal and I will do it manually at the content to show you how it will be bringing the content. Okay. So I will use the append to file. I will merge the file in this file. Okay. So Hadoop FS minus append to file, and the two local file I'm giving, my file and my file one. I will be giving the path of this particular file where I want to add more content. Okay. So test one, test two, and my file. Okay. Here I'm adding it. Okay. It take it another time to do. Stay. Stay. Can you see here? Here the additional content thing, right? Okay. So if I run it again one more time, you will see the log is appending. Yep, it's appending. Is keep appending. So tail command here is basically give you additional log content and additional content, right? You will be keep checking. Okay. This. So the test command is to test whether the file is a directory or file type. So we have a test command is there. Text command also like for checking, like we have a cat command and one command is a text command. Suppose some file is in the zip directory, I will show that one. Text command is to see the content of file in the zip. We can see using the text command. Okay, content we see. Uses is just telling what are the different uses for a particular command. Okay, so attribute you can see. RM command and RMDIR command. These are the two other commands. So RM command is removing a file. If you want to remove a file, okay, so you can use RM command. So test slash test1 slash test2 slash my file. So it will remove the content of the. So it is deleted. Okay, and if you use RMR, so that will delete your directory with the recursive. But if I say I want to delete everything in the test one, if I give this, so everything is deleted inside the test one. So you can't get the test two. If I try it, test two, if you do ls, you won't find it. Okay, so RMR is recursive, right? It is deleting recursive. So there is another command RMDIR, especially for the directory. So any directory you want to delete, like a empty directory or a specific only directory. So RMDIR command. Okay. And if you want to change the permissions, so we have a chmod command, but we have another command is there, FACL. So you can set using the FACL, set FACL or get FACL. Two command are there, set FACL or set F attribute. So attribute command is setting the attribute. Suppose you want to set some metadata. This is very important command. Sometimes you are not aware what this file is, because the file, unless you see the content of file, you can't know. Or even if file is very, very large, so you can't open the entire file, right? So sometimes we add the metadata along with the file. So there is a command set F attribute command. So F attribute command is setting the some attribute, like suppose I say this particular file is for like admin data is there or employees data is there. I just make it some attribute. Okay, so I can use set F attribute. So I say Hadoop HDFS set F attribute. This is and you can set some name attribute. Okay, so you say minus n name and minus v value. Okay, so I'm saying minus n name. I say minus v value is a test. Okay, some attribute I set name is the attribute name is a name and value is a test. And for which file, the particular file I can give and give the test slash. I set the attribute. Or followed by name must be prefixed to. Okay, I will show you. This command is basically setting the attribute, and once you want to check your value of attribute, you can do get F attribute, and you will just give the property name. What property you set, just give name, and you will get what value you set. So it is just like setting value and getting value. Okay, of your attribute. Okay, so this is the command, and the other command is the like find command. Find is for the find the files, like number of files you want to search. Head command is just get the top lines of the code file, like 10 lines you want to see. So Hadoop HDFS stat minus head. Okay, tools will do and then give the file path. Sorry, it's not okay. It will take the default line. Mhm. I think it is not taking any number parameter, so you have to give at the default lines are 10, right? Actually, it will be taking a 10 lines default. If your files is having already less than 10, so it will come entire content. Okay, so this we'll take a break and I will start next in the scoop. Okay, so in 10-minute break, I will start next component scoop. Okay, so I will keep it ready scoop like MySQL installation. Okay, so because for scoop we need MySQL. Okay, so I will keep it installed MySQL and then we will do. So I will follow this document MySQL installation on Ubuntu. This one to install. I connect in 10 minutes. Okay, then we continue to the school.
Okay, sir.
Yeah, hi everyone. You getting the voice? So now I'm installing MySQL. So when we are going to use Scoop, so we need MySQL. Server. And tool, which is bringing data from the RDMS database, any RDMS database, whether it's MySQL, DB2, SQL Server, Oracle. Okay. So we are doing practice with MySQL because MySQL is easily available and we can easily install and then we can do practice with MySQL. So you may get a chance to work on maybe Oracle, DB2, different. Service. Okay. Password. Here, you just keep it simple password. So password is a password here, and root is a user, and the local host is a same machine. Okay, and native password is a password. So I have altered the password, then I will exit. In with login with my user password. Okay. I will use MySQL minus u root minus p. So get password is a password. And here I have to create a one database. I'm creating a one. Okay, first we see two databases. All these are the default databases are there. I will create the one database. Scoop database and create. So now I have to install the Scoop also because I have installed source, right? MySQL from where the data is coming. But I need to bring the data in Hadoop file system using Scoop. Okay, so Scoop I need to install. So this very simple installation for the Scoop. Just you download the Scoop from the official website. The Scoop download and you put. So you will get the link for the distribution. So this distribution link you will go where you will get the binary, and this binary zip you download and set it in your home directory in the software. Okay, so this is Scoop directory, Scoop 1.4.7 for Hadoop 2. So this one we will download it. Okay. Rename this one so that we can make it shorter. Just keeping it till here because I should remember what version of Scoop I want on. And copying this one to my software. The software here I put Scoop. Okay, and now I have to set Scoop home and Scoop bin path. For the batch RC. Yeah, nano.bassrc. And I will copy this or I can paste space underscore on equal to slash on slash software like school 1.4.7 is the whole directory and the scope that we do path equal to dollar path, whatever my current path, I'm taking the path. Dollar path, colon, dollar school, underscore, blank, bin. So I have to set it to bin. Now I will come out from this, control X, shift Y, insert, and the source command that is important. And first, 1.4.7. But one more thing I have to do, what this two directory, I have to add my library jar. Okay. So I'm going to use MySQL. So MySQL library connector jar is not there by default. And one more change also, one common line 2.6, we have to take it. Okay. So this is, so we have to copy the common line 2.6 from the Hadoop directory. So that I have to copy. I'll go to I can download from the Google. Okay, if I have already installed Hive, so I can take it from there. Okay. So first I download the MySQL connector jar. So I just search MySQL connector jar. Okay. I have to use 5.1.47. So this connector jar I will download. Driver jar. I think this one driver jar is there. So this is the jar. Jar I will copy to my school clip folder. Okay, so one more thing I have to do, common line 2.6 tab. So that also I need to show. Common jar we will need it also Google JSON, right? First, let's see. So I'm creating the one table and database, right? So database I already created. I will create a table and I will import the data. So scoop is basically having the scoop import command. So we will use a scoop import command on the dollar shell here and import the data from this MySQL table to Hadoop file system. This thing already we done, right? We have sent the path and those things, dash RC to copy the MySQL connector jar and command line 2.6. This we have done. Okay. And we have already installed the MySQL and we changed the user, right? The password we have changed. Okay. So now I'm creating the database I have already created. Now I'm going to create a table. So before creating table, I have to use the database. Use Scoop. I will create a table. So I created an EMP table. Now I want to write some record, one or two records so that I can check. This is the one record. I want to add another record. This simple insert query I'm using to write the data into version. So select EMP. So I'm having a two record. Okay, so after once done, now I have to prepare my scoop import command. So how to prepare a scoop import command? So scoop import is a mediator tool which is connecting the source and writing to the data as a file in Hadoop file system. So when you are connecting to the source, then you have to provide a connect JDBC URL. We are using MySQL, so JDBC colon MySQL localhost, and this is the default port. Okay. Even if you don't give this code, it will take it default port, and Scoop is a database. And we get some SSL error, right? Handshaking error. So for avoiding that error, I'm using this SSL for defaults. If you don't use this, so your import will be done successfully without the, but there will be some SSL error will be there. So I don't want that error. And this slash is for the new line. Either you can write this hyphen hyphen in the same line. Okay, so hyphen hyphen connect, hyphen hyphen username, hyphen hyphen password. So my password is same, my username is same, my table name is same, and target dir, I'm creating a one directory path in my Hadoop file system as a scoop is a root directory, and there I'm creating a new directory. So this directory always should be new directory. If this directory is present, it will give you the error. Okay. So first time it will create it. First time is not a problem because you have no directory with this name. But the second time you will run the same scoop import command, you will get error. So there is a way minus delete target directory. If you use this option, it will delete that target dir and recreate again. So you will not get the error. So first I show you to just run this scoop import. And minus M1 is scoop is only mapper job when you are just selecting the data. But when you are doing some group by operation or count operation, some operation you are doing group by, so then it is map reduce job. So it's minus M1 is only one mapper job, right? It will be creating a one output file. But suppose you want to do parallel processing, right? You say, okay, you want to import 100 record into 4 output file parallelly. Okay, because getting the data is independent of like there is no conflict, right? So you want to finally you want to get all data. So if you have more number of mappers will be there, it will provide a faster way of accessing data. Okay, so there is a some constraint is there. You cannot go beyond that minus m parameter. Okay, because if you go like more than 10, right? So it will not be improving the performance, right? So there is a some limit is there. So till that limit, you can get more number of output files at the parallel processing. Okay. So this is a single threaded. This is only minus M1. But when I have some ID column is a primary key is there in my table, I can use minus M more than 1. Okay. In that case, I have to use split by column also. Okay. When I want to get minus N is more than 1. Okay, because I have to choose which column I want to distribute my record. So ID is a column in the employee table. You see the one column is ID column. In this column, it will decide how many record will go to in this particular file. This many record will go to in this particular file. So the splitting things will be done based on the ID column. Okay, first we are running very simple SQL this scoop import command, which is just importing the data into Hadoop file system. And there is a resource manager URL is there, right? We can track the job like monitoring we want to do. So there is a cluster, resource manager cluster address is there. So one I showed you UI of the name node, right? That is a name node, data node, right? Okay, storage part. But another one is a resource manager one, which is the processing logic, right? Whenever any job is running in the background, right? This is the mapper job. So this job 80884 that is giving for the resource manager. So any job which you started, right here I run the scoop job. So this scoop job is using EMP jar, and this is the start time, end time is coming. So here this is a scoop job. Okay, and this is it is saying here completed. So if I see the log here, so I can monitoring, I can do by here also. I can check whether the job is failed. So any output is if like we can debug the job in the resource manager. And another command is the yarn log command. So yarn log command is like I want to check the job monitoring. So if you see here, map input record 2, map output record 2. So this is a mapper only job. If you see here, it's a map 0%, reduce 0%. Initially, our map and reduce both are 0. But again, map is becoming 100%, right? My map all completed, but reduce is 0 because there is no reducer. Okay. So this mapper job is showing this is the progress of the job. And this is the URL, like same URL which I opened, right? 80884 and the local host. And this is the application ID of my job. So if I want to see this job, like there is another command line command I can see. So yarn log minus application ID. And then we can give the application ID value. This way, here it is not coming, the job is completed. So we can see this command line way, we can see the log or we can see the UI. Okay. And when this scoop job is completed, so I have given the scoop folder in my Hadoop file system. Hadoop access minus ls slash scoop one. So first we see check my command. I given this command, right? So I given scoop I given. So I given scoop directory. So scoop directory has scoop 11 I created. So scoop 11 again a directory. It's not a file. It's a directory. And inside this directory, my output file is created. That is a part M file. So whenever your output is coming as an output file is a mapper file, mapper output. So it will be part M. And when your output is coming as a reducer output file, the file naming convention will be part R. Okay, so when you see the map reduce job, when we will be running a map reduce job, then you will see part R also there. Okay, so that is a manual way. We are writing a map reduce job and we are generating the part M, part R file. But here scoop is by default giving part M if we are not doing any processing of the group by queries like that. Okay. So part M file, now I want to see the content of this file, whether it's the same content what I'm importing the data from the audience. So part M type from 50, and I will do a tag. So I will see comma delimited characters. I will see the data. So I will see the ID, name, age, right? What is the problem? So I have created a table. In that table, ID, name, age. So ID, age, and name. So this three field data is coming here. So if you see here, this is a comma delimited. Default delimited character is a comma. But there are many other attributes are there. If we change those attributes, we can change our result. Okay. So suppose first, okay, if I run this job again, what error will come? If I run it again, because my directory is already there, right? Scoop 11. So it will say the scoop 11 directory is already present. So scoop 11 directory is already exists. So this error will come. So if I don't want this error, I will have to add deleted target DIO. This option I have to add in my command. So it will delete the target DIO before creating a new record. So when I want to use it, so I will add it. This one. So now it will, every time it will delete and then now it is not giving me error. Okay. So this is the one option. Suppose this data is coming comma delimited character, but I want it should be field terminated by $. So if I add this one more attribute, so my data will be coming as a $ terminated, okay, not the comma delimited. Comma delimited is the default one. Okay, now we see other options. If I want to increase the number of mappers, okay, so I have to use split by column and then I can increase the number of mappers. So if I use this command, so I have to verify everything is correct or not. Scoop to password target DIR is scoop 5 / scoop 2. So this directory is not present. and split by column and use. Okay, so this one is completed. I'm not verifying it. And I'm running with the another command with the minus n parameter. Two. So here the two output file will come. Each one have one record. So it will distribute equally the number of records. Okay, so my table has two records. Okay, when I'm using minus M2, and it will take it to 5. So I just go to the and look directly. Directly name I giving scoop/scoop2. If you see part 0 and part 1, part and view. So I check it part 1. And here I can see. This command are very, very simple, very easy to do practice. Just understand, like, because in interviews they will be asking, okay, how will you make it parallelism, right, in your scoop job? You should know, right? You have to give the split by column, you have to change minus m parameter. So you have to do this. Okay. So if you know the proper attribute parameter, scoop is just only configuration. There is no programming, nothing is there. Just you have to understand the basic purpose of the command and how to use it. And you have to verify the data, right? Once the data is imported, then you have to verify. Even we can do export also. If I have some file in my Hadoop file system, I can write a table in MySQL. So import and export both we can do using the scoop. Okay, so this one we've seen that minus n parameter one. Okay, field terminated by and delete target directory. Okay, I'm not just doing this. You can do practice. Suppose right now you are using minus table only. So by default, it is bringing all the columns. It is bringing all the columns. But if you give minus column, so you can bring only specific column. Okay, so that part you can try. So you can give additional minus column. Or even there is a one more option minus where. If you give minus where, and then you can give the condition, right, ID greater than 1. So ID equal to 1 will not come. So there are the 3 attribute, right? One is minus table, right? In the school. Minus table, that is the default. So if you are not giving anything else, it will bring everything. The another one is the minus column. So minus column, minus columns. So minus columns, if you are giving, okay, I want ID and age. I don't ID and name. I don't want age. So ID name you can minus where you can say, I can say I want ID is greater than 1. So ID equal to 1 will not do. So this is like condition, this is like selecting the field, and this is the table. Okay. So if you give only this table, it will bring all the columns, all the data. So this is the like a filter. Okay. So there is a one alternate option is there rather than giving all these 3. So they have given the option minus query. So query is an option like a free form query. So you can write your own query, right? Even the join query. So here you are importing the data one table at a time. Okay. You cannot do 2 tables at a time. The only possible way to bring the 2 tables data as a single table when you are using a join query. Okay. So this minus query is giving the feature like you can get the data from 1 table or 2 table or more than 2 table. So you are giving a query. So let's start from EMP and you say where ID greater than 1. So you can write this query and here you can give the specific field. It is equivalent to the of these 3 attributes, ID, name. But one more thing is here, when you are using this, you have to use dollar conditions. The dollar condition parameter, this one, dollar condition you have to add in your query. Okay. So when you are writing a free from query, this is called free from query. So you have to provide this dollar conditions. The dollar condition you have to give, and whatever condition you want to give, you can give additional condition. If you don't keep it other condition, but still the where clause will come. This dollar condition will come, whether you want to give other condition or not, but dollar condition will come with the where. Okay. So I want to write a free from query. I want to get the data from EMP table for all the column and for the ID is greater than 1. Okay. And I'm saying here I want to delete target DIR. I want to do that. So even this directory is not present, scoop 3, so it will work fine. And here I'm saying field terminated by $. Okay, so I run this. This is the complete one. This is completed. Only one record came. Why one? Because I given ID greater than 1. Because I have given the filter, so only this record came. Okay. So when my folder is a scoop 3. Scoop 3 file naming convention will be the same, part n. When you see here, and the data is coming $terminated, right? So $terminated, only one record came. So this is like free-form query, right? How to use free-form query. If I want to see all the databases list, right? I want to see how many databases are there. This is not a scoop import command. This is list data. This is a scoop utilities. Scoop import is a one kind of utility and which has multiple attributes are there, parameters are there to enhance your scoop import. Another utilities are there like scoop list databases, scoop list table, scoop import all table. I will show this one. So here, scoop import, this can be done. Scoop list databases. Suppose I want to know how many databases are there in my MySQL. So I'm giving here localhost 3306, but I'm not giving any specific database name, right? So I'm just finding how many databases are there in my. So it is just giving me information how many databases are there. So I'm getting the list of all databases in my MySQL. I want to know how many tables are there in my particular database. So I'm running this scoop list table command. Yeah. So anybody is asking to you how to find the list of tables. So only one table is there so far. Okay. So I'm creating a one more table and just I'm giving the name so that I will show scoop import all table. Okay. So I'm create another table with the same name. Means like different name. I'm just making a different name and I'm inserting data in this table. Okay, show tables. So there are two tables in this scoop database. Okay. Now I want to do scoop import all table. So by default, scoop import only for one table at a time. But if you have more than one table, right, and then you want to import all tables in, but here is we don't need to give the target DIR. The target DIR, it will take it my Hadoop file system root directory. Okay. So if I see Hadoop FS -ls. So here, right now, no directory is there. Okay. First, I do scoop import all. So what is scoop import all command is there? Scoop import all. It will take my database name, okay, and username and password, and I'm not giving any target here. Whenever it is running any job, it is creating a jar with the name of the table. Okay, so if you have seen here, emp.jar is there, right? So basically, what Scoop is doing, it is creating a set of like this. It is basically doing the database connectivity, right? Some JDBC connectivity. So it is creating the jar and classes up there. Okay. And then it is importing the data. So 2 times it is running, right? 1 time it is completed. And the second time for the second table is there. If you see emp1.jar. So an emp1.jar having the emp1.java class. And this Java class has the code. So basically, whatever command you give, it is converting into the MapReduce job. So emp1.java class is there in the emp1.jar. And basically, this class has your code, right, which is running in the background. A MapReduce job, it is running in the background, and then it is executing it. So this one is completed. Now you see, previously I was not getting this directory because there was nothing was there. But by default, when you are importing all tables, your tables will be coming with the table name folder here. So all table will be coming here. So EMP1, EMP is coming, EMP1 directory is coming. If I want to see EMP directory folder, so EMP1 has again part and success. So I want to see the content of part and 1.000. See the cat command. So I will see the same like two records, the same for the EMP also. Okay. So it has imported both the table. It has imported both the tables in home directory of the my Hadoop file system. Okay. And once there is a one option is there in the import all table. Suppose there are the 100 tables are there and I don't want only one table. So I want to exclude one table, and this table I can specify there is a attribute is there exclude table. And when I give this exclude table, so what it will do, it will skip this table. So when it is going to run import command for each table one by one in the database, so wherever it find this department table or like my another table I want to skip, I say EMP1. Okay. So I want to modify this one. So EMP1, because I don't want EMP, I want only EMP. So if I want to run it again, my folder is already created, right? So that I need to delete first because right, if this location already have these two folders in directories, so it will not import. Okay, so I will delete it. So fs minus rmr, and I say emp and emp1. So both are deleted. Now, again, nothing is there. Okay, so nothing is there. It's empty. Now I'm running a SQOOP import, and this time SQOOP import, I'm giving exclude table emp1. So what it will do, it will import all table except this. So I have two tables only. So one will be exclude and one will be include. I'm running it. So these questions can be asked, right? If you have 100 table and you want to import 99 table, one table you don't want to. So you will not do 100 times import command, right? 99 times, right? So they have given option. You can do import all table and do only one table you can exclude. Okay. Now if I'm just checking this Hadoop FSLS, I'm getting only EMP because EMP1 I excluded. So if you see our, like you will find somewhere it will skip. So it will be saying that skip EMP1. It is started. So somewhere it will be coming skip EMP1. Okay, this is the first one. Once it is completed, yeah, it is coming. Skipping table EMP1. Again, suppose you have more than one table you are importing. So all tables will be do one by one, and when that table is coming, then it will skip. Okay, so next one more document is there, that is a SQOOP job and incremental load of the data. This is the most important concept in the SQOOP, right? SQOOP job, right? And how to do SQOOP incremental load. So data is not only one time you are loading into the Hadoop file system, right? You have to uh, do the incremental load, right? Today, some data you got it, you load it. So if you are not having any incremental process, so what will happen? Suppose today you got 100 records and tomorrow you got 20. So what you want to do? You want to import only 20 or you want to do again 120? So definitely you would not like to import all 120 again, right? Because it will be taking time process. And why unnecessary? I will import the 100 record which are already imported. Okay. So in incremental load process, I'm giving on the specific record, right? I'll tell right how many record I want to do. Now question comes, how Scoop job will come to know what was my last record imported. So Scoop incremental load process, there is a last value option is there. So whenever first time your Scoop job is complete, Scoop import is completed, so last value you will be given. You will be given last value. So you should remember this value. Yeah, you copy this value to somewhere else. And if you forget this value, it will be very difficult to find out what was the last import you done. So that was a drawback in this incremental process. So we will go for the Scoop job that will remember on behalf of me what was my last. Okay, because I don't want to remember this, right? Because if I forgot it or if I missed it, then I can't do my incremental load. And this is like a manual tedious job, right? Like to remember it manually. Okay, but we will test it once, right? How this last value works. Suppose you are going to do incremental load now only. Okay, so you can remember it. Okay, so I have created a Scoop import. I just given a same parameters, username, password, table, same EMP, and target is my target directory. I'm creating a Scoop slash incremental folder. And here is a parameter I'm giving incremental append. And there is a one more parameter check column, which column it will check the last value. Okay. So that column is the ID column because there are we are giving the value is the number value 1, 2, 3, 11. Okay. So when I run the command, how many record will be imported the first time? There are the 2 record, and this last value will become 2. This last value become 2. Okay. Because I have only 2 record in my table. Okay. So I'm doing for EMP table and I'm saying this is my, and here when I run it, I will get here last value 2. Okay. So I run this. Can you see here the same statics which I shown there? The same is coming. Incremental is append type, check column is ID, and last value 2. Okay. So now this last value is 2 they given. Okay. So now how I can modify my command to run to get additional record. So first I will add some more record, right? Because otherwise, how can I get it? So in the EMP table, I have the last 2 records are there. So I'm adding 3 and I'm just giving any name. That's going to be 3 and any age. Continue. So I inserted one more extra record. If you see here, let's start from EMP. Now I have a 3 record. And last time I imported 2 record. So I want this time this 1 record. Okay. Now in my Scoop incremental command, this is my last command, but I have to add one more parameter, last value. If I don't give this last value, so it will not understand. Okay. So minus last hyphen value. And whenever you are giving a like 2-word parameter, 2 words parameter, right? Last and value, okay, and check column. So first parameter will be 2 underscore 2 hyphen, and second one is a 1 hyphen. Okay. So last value, what I give 2. So when I say 2 means it will understand 2 are already there, and now you have to start from the 3. Okay. So now I'm running it again. It is the same only. Actually, I have directly modified here. Okay. So when you see here, I have just added here last value. Okay. So for practice purpose, you will see all the commands in the document, so you don't need to worry. Okay. So this time, how many records should come with this incremental load? Only one. Okay, so if you see little above here, one is coming only. Okay, and the last value has become now 3, right? So we will verify it. So every time whenever you import, it will create a one separate file, okay, for each import. So what is my import directory? My import directory is incremental directory, scoop incm. Okay, so if you have to use merge command, there is a merge, right? So if you have already, if generally this case will be right when your MySQL data is changed, right? And you want to merge your record in your local file. Okay, so there is a merge option is there, so you can merge it. So that I will show you that merge option you can do. First, the basic option you can do. Here is a scoop like incr. So here 2 files will be there. The first time the file is created at 11:54. The second time when I run the second time incremental load, it created a new file. So every time data is separate data is there. If I check this particular file, I will get 2 records. So I will just scan command. Then I will see the part 1. So 1 will be there, right? This is the incremental load. Okay. So you understood it. This is a manual, right? This is a manual incremental load. Now I want to make it this incremental load process automate, right? Because I don't want to keep remember this last value and I have to provide in my command. Okay, so every time I have to remember. So there is an option scoop job, and scoop job not only for incremental load, and it is used for any scoop import command. So you write your scoop import once and use many number of times. You don't need to write the complete scoop import command here again and again, right? You are not writing scoop import again and again. So whole scoop import command you don't need to write. Whole scoop import command you don't need to write. So you will define a once job. So there is an option create option is there. So you have to write like this scoop job hyphen create. And after hyphen create, complete import command you will give as it is. So suppose I have my scoop import command this one. So I will copy this scoop import command after the import like this. I will copy this part and I will copy paste to after here, right? Driver is not needed. This will connect. Okay. But one more thing I'll tell you, this scoop here you write scoop and import together, scoop and import. So can you see here, scoop and import, there is job is coming, create is coming, and hyphen also space is coming. Okay. So just remember it, this is like a prefix thing. So this prefix driver is, even if you remove the driver, it's not a problem. So when you are writing a scoop job, so just remember it, this space is very important. If you have not given this space, so your scoop job will not be created. So scoop job and then minus create and give the job name. If this job is already present, it will give you the error. It will create a one job for you. Scoop job will create and nothing will do. It will not do any import. It will just create a job. So when I copy paste this one, and I'm giving a different directive to test, okay? And incremental append and check column. Everything is same in this one. Only thing is I have break up this command to one as a job, right? I have in this, it will not do actual import. Actual import will be done when I'm executing this scoop job. See, right now it's just creating job. So one error I'm getting this JSON error. Okay, I told you like we need some JSON library. Okay, because this error comes, so we have to put library some JSON jar. So these are the predefined errors. These will come definitely. Even you are using Scoop or I'm using Scoop, because these are like already Scoop has not provided library with all specific jobs which is needed. So if we go to the Scoop library folder, if I go to Scoop lib, so here in the Scoop, yes. So Google JSON jar, I will download it. Just right? So hard to expect it. So this is a just inside this. This is jar. Now I will try to create a new Scoop. So in this scenario, it has created last time job. Okay, so I have to give the different name. And you cannot modify the job. That's the problem with the job. So whenever job is created, only option is you can delete it. Okay, and you can recreate with the new configuration. If something, suppose you want to change table or you want to change the directory or you want to change username. So anything you given by mistake, right? So you cannot modify it, the job. The job is created once, so you can. I'm putting this library for our job of this library. Who are we using this name? This name. Okay, we schedule this job. Yeah, we can schedule the job, right? We can schedule the job, right? We can have to use some scheduler tool like UG, Airflow, right? We can do. Okay, but Scoop is just not like a job. Scoop job is not a scheduler, right? Scoop job is just running, just giving an automation, right? Like you don't need to recreate an import again from the scratch. Okay, so Scoop job is just giving you the reusability, right? You can create job once and then you can run multiple times. So that's a benefit only. Okay, but you can schedule job through Airflow or UG. They have the action. Okay, Scoop action is there, so you can try that. This job is already created, right? So I have to try with the new job. Error is coming, but this job will not work, right? Because it came with the error. Okay, so it was not successful. This time you didn't get any error, right? But job is created. Now there is an option, Scoop job minus minus list. So you can see how many jobs are there. So we already created 2 jobs, but those 2 jobs are now properly created job because an error came. So job 3 is our working job. Okay, so we can find out which jobs are not our use, right? We can do minus minus delete scoop job minus delete a job one. Because we can do one. Okay, one time, one. So my job one, my job two. Okay, so now again I do scoop job list. I will get a scoop job one is not deleted. My job one. Okay. Now I do scoop job list, only job three is there. Okay. So delete command is deleting the job, list command is listing the job, scoop job create command is creating the job, and scoop job minus minus show will be showing the metadata of the job. So here, the scoop job metadata, you will see the last value parameter. Okay. So, but the scoop job has a security, right? It will ask the password again, right? It will ask the password. So it will ask one more time extra password so that you have to see what to do. If here I have not made any incremental, I just created a job. So first time you will not be able to see the last value option. Okay? Because last value will come here once your first time import is done, right? Suppose you first time importing two records. So last value will come here minus minus last value equal to 2 will come. When you do second time import, then your last value will become automatically 3 year, 4 year, how many record you do import. Yeah. So now I have created job, I have show metadata. Okay, so abhi still is not coming. So what I do the execute command, scoop job execute. Okay, minus minus exec. So first what I do, whatever job I created, I run it first. Scoop job minus minus exec, and I give the job fee. Okay. So I'm first time I'm loading the fee record because my table has fee record now. Okay. So maybe part it's an old terminal, right? So that is that's good job. So again, it is asking password, whatever your MySQL password you gave it. The new error is coming. Okay. So in this command, actually database scoop one we gave, that is wrong. Okay. So this scoop job is created wrong. Okay, because we created the scoop job. If I see job three. So I have created the wrong one. Please scoop job three. The database scoop, not the scoop one, because we don't have the database scoop. Here, so this thing, so you should be careful about when you are creating a job. So what database, everything you should make sure, right? Everything is correct. Because once the job is created, you cannot delete it. And the target directory, because now I'm changing it because the directory will be already created. So now I'm creating a with name job one is not there because job one I deleted. So I'm creating a job is created. Now I want to execute this job. I don't want it. So that's the password. Running, but this job now running with the scoop job full scoop job. This incremental job is running full scoop job. So how many records are imported? 3, because my SQL table has 3 records. Okay, so I just verify the location. Hadoop HDFS SQOOP slash INCR2, because I see in the directory, new directory, INCR2. So this part M file, this part hyphen. So that is fine. This is the first time import. I mean, right now there is no incremental. Yeah, I have already done the point. So here I'm going to insert one more record. Okay, let's say 4. I inserted only one because I'm just doing testing. Okay, now I'm running my scoop job. So just I have to do scoop job minus exec and my job 1. Again, I'm running. So this is the reusability. I run my job. Password. So only this time it is not importing. It is same process incremental. Only the new records are coming. But the advantage is the last value I didn't remember, right? What was the last value? So you will see what is the last value now. Okay. So now we go to scoop job minus show and job 1. So when I see my job 1. Okay, so when I check metadata, if I check here metadata, my metadata will be last value 4, because I have inserted last value record 4. Okay, now again one more time incremental. Actually we missed it, right? First time when we did 3 record, that time if we check the last value, it was 3, because we have done one time incremental and we got one more record. Okay, now if I do one more time incremental and now I'm giving record 5, I'm giving a 1 record 5 and this record I inserted. Now I'm running my, this is the last value you are able to see 4. Okay, now I'm running job again, scoop job execute. This is the automation through the scoop job, right? You are not writing scoop import command again and again. And especially for the incremental load, we are not able to remember. So this is, so now if I look at the data location, okay, if I look at, so only one will come. As per this, only one record will come. Record 1. Okay, so only one record is coming. If I see here my incremental 2, so how many files are there? Part, this is the last one. Okay, so the data is there. Okay, now we check the metadata that we have to use. So jobs on metadata. So if you see here, the last value 5. So you don't need to remember, right? So this is the way using a scoop job you can do the incremental load. Okay, that I want to show you. Is like, suppose you have to modify record, right? Suppose you are getting some new record or some existing record you have changed. Records are same, but some records are updated. So that one we have another incremental modified timestamp mode is there. But in that case, you need a date column. Okay, I will give that example also. So in that case, you are using check column ID, but in that scenario, you should have check column, some date time column is there. Because date time column will be updated. That time, suppose you have first time, today date time is there. Okay, after 2 hours, you change some data in your MySQL. So your timestamp is changed. So it will automatically check, your scoop import will check which record is greater than your current timestamp, right? So then it will do. Okay. So that one is another example of incremental, but the modify timestamp mode. So there are two modes are there, append mode, and another one is a modify timestamp mode. And there is a check column is the ID in the append, and the modify timestamp mode, the check column will be some date column. And next is a Hive import, and this one let's do tomorrow. Okay, so you can, I will give you the this scoop import file, and this workshop folder, I will complete folder I will share to you. Okay, so day one you can see this all files and the PPTs, everything is already there. You can access it. Okay, and this recording I will upload it on the YouTube, and then you can watch. Anyone has any question? Okay, I will share recording and give the link, the YouTube link once uploaded, and you can watch. Okay, and those who are already attending classes, I will upload in the classroom. Okay, so you can see. Okay. Those who are not attending classes, so they will see in the YouTube. Okay, yeah, thanks everyone for attending session. So tomorrow I will cover MapReduce and whatever part of the scoop is pending, and MapReduce and Hive and HBase. Okay, so Hive will definitely take more time. Okay, let's see that how much can complete it, because otherwise I will be doing the weekday session. We have to do all these things. Some of the part we will revise, and some of the pending part will come. Okay, thanks everyone. Thank you.
Thank you so much.